Hello everyone, welcome to my YouTube channel. In the last videos we have discussed in REFPROP 10 about the options, and we set the options, and then we saw what are the substances in which we saw all the refrigerants data is available. And now in this video we will see the calculate tab, and in this tab you can see there are further sub tabs, and this calculate tab actually is used when you need data in the form of tables. And let's see so what options are there and how we can evaluate different data. So first we have to select a substance on which we for which we need the properties. For example, let us select ammonia in this case, and then we will go to calculate tab. So in the calculate tab, the first option is about the saturation table. So let's see what's inside the saturation table. So as you know, like there are three types of saturation data available. The first one and the mostly used data is the vapor liquid saturation data. So here it is also displaying us a pressure temperature diagram, and these dotted lines are telling you about the type of data you have selected, which is vapor liquid saturation data. So here is the vapor phase, and this is the liquid phase, and this is the solid phase. So the vapor liquid saturation data is actually giving you this line data, which is the saturation data between the vapor state and the liquid state. And here is the critical point. So when you will change it, you will select the solid liquid saturation data. It will actually is giving you this data, which is between the solid phase and the liquid phase. And if you want the solid and vapor saturation, that is the sublimation line. So here is that solid and vapor data. So the mostly used data in HVAC refrigeration is the vapor liquid saturation data on which we work. So let's see what we can evaluate from REFPROP 10 from this vapor liquid saturation data. So the next tab shows that what thing you want to vary. So if you want to vary temperature in this curve, or you want to vary the pressure, or you want to vary the quality at fixed temperature, or you want to vary the quality at fixed pressure. So let's see. First we will vary the temperature. Let's select temperature, and we will select OK. And here, as we have selected the temperature, so it will ask from us from which temperature range to up to which temperature range you want to see the saturation data. So for example, it is -70 to 130 degrees Celsius, and the increment is 5 degrees Celsius. And we will just press OK, and it will display you in the tabular form all those properties which you have selected in the options. It will display to you, and here you can see it is varying the temperature with the 5 degrees Celsius increment from -70 up till 130 degrees Celsius. So here you can get all this data, and here you can see you are having temperature, pressure, liquid density, vapor density, liquid enthalpy, vapor enthalpy, liquid entropy, vapor entropy, and CP values and viscosity values. So all the things which you have checked, which you want, it is displaying you all those properties. So what you can do, you can just copy this table, and you can copy and paste it into Excel or wherever you want. For example, now you will go to this edit tab, and you can copy all the table data, or you can copy just the selected data and you can paste it. So for example, we'll just copy all table data. We will just go to Excel, and we will just paste it here. So here all the data will be pasted. So in this way you can save this data in the Excel sheet. And another way of saving the data is that you will just go into the file option, and you will select save tables, and it will check all the tables available, and you can select which table you want to save. And it will say like you want to include column headings and include row number. So row number we don't need, we just need the column headings and all this data. We will select that data, and it will also give you options of having spaces between this data, or commas or tabs, and then you will just press OK, and it will save this data in the text form. So in the desktop, let's save and name this file ammonia, and we will just save this file, and we can see this file from the desktop. It is saved in the text format. So here you can see this data is saved in the text form, and it also has the headings on its top. So here is this all data. So another way, if you want to import this data into Excel, is that you can also open this text file with Excel, because text data you can also open it with Excel. So let's see, and here is our ammonia text file. So we will open it in Excel, and it will ask you few things, and when you will select those things, it will create it into the tabular form. So here you can see that it has saved your data in the Excel sheet also. So these are the ways by which you can just copy and paste or export your data into text file or Excel file. As you know, the text file is also supported by Excel. So from here we will just move on. To just give you a view of this data, we will just also plot it, and we will see what is actually we were getting actually. So this is the TS plot, that is the temperature entropy plot of the ammonia, and what we are getting actually is that we are getting this part. Let me zoom it for you, and let me cascade the window so that you can easily understand. So this is, we will just cascade the window so that we can easily see. So what actually we are getting in this tabular form is that the temperature we are varying. So here you can see the temperature we are varying, and we are getting this saturation curve points, which is the liquid saturation line, and this is the vapor saturation line. So these points actually are we getting. As you can see that this is the data for the liquid vapor. So actually this is the liquid vapor saturation line data of the dome. So this is what we are getting. So next, what we will do after this changing the temperature, and in the calculate menu and in the saturation table, we will check how to vary the pressure. So next is that we will vary the pressure, and for pressure, let us, it has by default has taken the value from 1 to 110 bars, and with an increment of 1 bar. So let's see. So here you can see it has given us the data, and now it is, instead of temperature, it is varying the pressure with an increment of 1 bar. So here is all the tabular data for it, and what is this data actually is that we will just go to the pH diagram, and we will just plot its pH diagram for to show you what is actually we are getting here. So this is the pH diagram of ammonia, and again here uh, we are getting the same points, actually the DOM values, but just to show you the TS and pH diagram of ammonia also for your for the clarification. So here what is we are getting is actually we are varying the pressure, and we are getting all these points and along the dome, that is the vapor line and the liquid line. So this is what we are getting here. So after that we will just close these boxes, and we will move on. So another important thing which you can calculate in this saturation tables is that in the vapor liquid saturation, if you will go instead of temperature, you want to calculate or see the quality change at a fixed temperature, you will just select to vary quality at fixed temperature. And for example, for ammonia, we want to check its change in quality from a temperature of 10 degrees Celsius, and it will increase the quality starting from 0, that is the liquid phase, up to 1, that is the vapor phase, with an increment of zero point 0.1. So here you can just get this table in which you have fixed temperature and the pressure is also not varying, and here you can see how the quality is varying starting from 0 to 1 with an increment of zero point 0.1, and you can see the phase is changing from liquid phase to the 2 phase and then finally to the gas phase. So if you are working on some heat exchangers, and it is like for example, it's an evaporator and it is changing its phase from liquid to gas phase, so in between these two phase you can get all these properties with an increment of your requirement. You can see how the properties are varying. For example, the enthalpy is increasing and the entropy is increasing with the quality. So with this we have completed the saturation table, and we have also seen the vapor liquid saturation, and we have seen how these varying these parameters we can get the parameters. And another thing you can get, you can similarly you can get this solid liquid saturation, that is the melting line, and you can also get the solid vapor saturation, that is the sublimation line for some sublime components like CO2 or naphthalene or other sublime materials. You can also get the sublimation line data. We can see like in the calculate tab, after saturation tables we have the next sub tab, that is iso property tables. So let's see what's inside the iso property tables. So as their name indicates, iso means same. So here we can, what we can do, we can generate different tables by holding some variables as a constant. For example, we can hold constant temperature and we can vary pressure or density, or we can hold constant pressure and we can vary temperature and density. So let's see, if we are holding a constant temperature and we want to see different pressure, we want to vary pressure, and let's see, it has a temperature of 25 degrees Celsius which will be constant, and now we will vary the pressure values from 1 bar to 300 bar with an increment of 1 bar. So here we can see it has generated for ammonia constant temperature, the pressure is varying, and with this pressure varying you can see at the 25 degrees Celsius, which is the ambient temperature, you can see at atmospheric pressure it it is present in a superheated state and in the gaseous phase, and at 25 degrees Celsius and at 10.027 bar it changed from superheated to saturation point. It reaches the saturation vapor point, and the value of quality becomes 1. And similarly at the similar temperature and the similar pressure, it changed from the vapor line to the liquid line, and you can see the phase is changed into liquid. So in this way, in this table at a constant temperature, you can see what type of phases are available, and how the properties like density, enthalpy, entropy are varying. For example, at this temperature you can find this gas, at superheated state you can find is the subcooled phase, and so this is the table, you can see like different phases, at which pressure it is in gaseous state, at which pressure it is in liquid state. So usually you can use this type of tables if you are working on some vapor compression cycle and you want to see in which state your refrigerant would be at different pressure levels or at constant temperature, maybe the evaporator temperature or the condenser temperature. So this is the use of these tables. So let's move on, and in the calculate tab after the isoproperty tables there is the phase boundary table. So let's see what's in the inside the phase boundary tables. So here you can see it has defined as like we have to give it the density value, and it has on default taken the value from 1 to 890 kg per meter cube with an increment of 1. And let's see what it gives us. So it gives us also the similar properties, like here it shows like some rows in italics have warnings. So when you calculate or RefProp calculate some properties which are very near to the critical point of the component, so it gives also some warnings. Like here it has given some warnings, and the warnings, so it shows that rows shown in italics have warnings, and when we will click on the row it will tell us the error message. For example, here you can see these are the accurate data, but when we will go below after some density point, you can see the result will change into italics form. So this is the italic data which has warning. So when we will click it, it will give you what is the warning in these values. One or more inputs are out of range, pressure above the upper limit, that is P maximum 1000 MT. You are doing or in your research, we don't consider these points, and we consider these points are not correct. So what this table is providing us here, it is changing the density. So here you can see like temperature and pressure both are varying, but the main key parameter I would say is the density, and it has started from 1 kg per meter cube density, and it's keep on increasing the density value. And you can see with increasing the density values how the temperature and the pressures are also varying, uh, increasing. And the here you can see the phase shift from the gas to the liquid state, and then from liquid you can see the quality is also changed, and then there are some warning messages. So this table, if you want to like see how the density, with varying the density, how the pressure and temperature of your refrigerant or component is varying, so you can use this phase boundary tables. So after this we will move on. We will just close this window and we will see what is next. So next is the specified state points. So specified state points, if you have seen like in calculate we have different tables like saturation tables, isoproperty tables, and phase boundary. So these are all the tables, but this mini tab, or you can say the sub tab, it has the specified state point. So it is used if you want some specific state points, and for generating the state points which are not on the equilibrium, you need two points or two variables to be described. For example, if for the ammonia you will specify at 25 degrees Celsius and 1 bar. So when you will define and you will enter, it will give you the other properties as you can see. So you have to define the two state variables, and then you can get all the properties. So if you are working on some vapor compression cycle or some refrigerant, you want to know the 4 or 5 state points, like in the evaporator, after compressor discharge, and after like in the condenser subcooling, and after expansion. So you can just put the temperature, pressure, or the quality values, and you will just get all the state points. For example, if it is uh, in the evaporation, we will, let's say it's the evaporator temperature is -10, and we can see the quality. If it is in the evaporator, we'll just see it is at 0, and you can see at this temperature the pressure will be this, the density will be this, the enthalpy will be this, and it is in the liquid stage. And similarly, if it is in the condenser, you want to see, suppose at 40 degrees Celsius, and you want to see at saturation vapor line, so you can see at 40 degrees Celsius the pressure will be 15.5 bar, and you can just see the change in the difference in the pressure. So this is like for specific points. If you want to see the specific points, you use this tab. And similarly with this tab, specified state points, so there is a saturation points at equilibrium. So you know that at equilibrium you don't need to specify two state points, and you will just state one point, that is 10 degrees Celsius, and you will get to know both the points in the liquid saturation line and in the vapor saturation line. All the properties you will know, so you will just state one parameter or one state point, and you will get all the other properties because it is at the equilibrium. So this is all about the calculate tab, and in the next video we will move on toward the main or important tab, that is the plot tab. So if you like this video, please like and subscribe my channel. Thank you very much.